Well, hello again, and it's time to do some SAT assignments because recently I assigned this type of work to a student of mine. You may know her as Moonie. She is one of my mathematics students of mathematics, and by tomorrow she's supposed to do a few assignments taken from that SAT manual which I've got. And I thought to myself that it would be a good idea to let you um, take a chance to do the same assignments. Why not? Okay, as usual, let me give you a word of advice. Before you get down to watching the video, I strongly recommend that you make a pause just as soon as you see the assignment itself in order to crack it on your own. And then only should you continue watching the video in order to compare your answers with mine. Okay, I guess it's not only fair but effective for your, I would say, further intellectual, um, let me say, development. Okay, so let's get down to the first assignment. Here it is. In my not humble opinion, these assignments are not very difficult to deal with. Okay, now the first one is the following. If n is a negative integer, which of the following must be a positive number? Okay, what do we know from this task is that n is a negative integer, right? Integer, for those whose native language isn't English, it's such numbers as, for example, 1, 2, 3, -4, -10, etc. integer, okay? So, and in this particular assignment, in this particular problem, n is not only integer, but it's negative, okay? Now, and the question is, or the assignment is to choose or to opt for the correct option. Let's take a look at the first one, n plus 2. So if we take n, which is more than 2, in terms of its absolute value, I mean module, in this case, we will get a negative number. For example, if we take n, which is equal to minus, let's say, 3, we will get -3 plus 2, -1. And we are expected to get a positive number. For that reason, option A is incorrect. Let's take a look at option B, double n. Okay, twice n is -2 because n is negative, 2 is positive, and the product of 2 and n will finally give us a negative number, which isn't what we are looking for. For this reason, B isn't the right option either. Now let's take a look at 2 times n plus 4. It is the expression given in option C. So for the same reason as I mentioned in explanation related to option A, this cannot be chosen as the right answer. Why? Because n can be n is negative first, and it can be large enough to make the sum negative. For example, if we take n, which is equal, let's say, -3 again, we will get 2 times -3 plus 4, -6 plus 4, and we will finally get -2, which is negative. And this is not what we are looking for. So for this reason, no, we say no to option C. Now, n squared minus 5. Yeah, you may say, oh, squared, it means that whatever n is by nature, negative or positive, its squared value will finally give us a positive number, and you will be right. But the problem is that just right after n squared, we've got -5, which means that actually at some values of n, these algebraic sum can turn out to be negative. So, for example, if we take, let's take n, which is equal to -1, for example. Okay, we will get -1 squared -5, that would be 1 -5, and the final is -4, another negative number, and this is not what we need. Another example, when n is equal to -2, if it's squared, so it will be 4, right? And 4 minus 5 will be -1, another negative number, another negative outcome, so we don't need it at all. So we say no to option D, 2. And the last one, so it is as clear as day that this is what we actually need, because n squared, as I've mentioned above, is always positive, and +1. So when we add a positive number to something positive, at least not negative, right? So we get a positive number. So this is what we actually need. And the correct answer is option E. That's all. As you can see, it's not very difficult to deal with. I mean, this particular question, of course. So we are just through with the first question. Now we're proceeding to the next one, which is going to appear on the screens of your computers in no time. So here it is. The text of this question is the following. Ashley is 7 years younger than Sarah and 3 times as old as Cindy. If Cindy is C years old, how old is Sarah in terms of C? So those of you who are not good at algebra may find this particular question challenging. However, I would say that it is as easy as a pie. I will tell you why, because this particular question is based on pure logic. Logical thinking is a very good, I would say, foundation for those of you who are going to take the SAT, because if you follow logic, if you follow not intuition, though intuition plays a vital role too, so you are very unlikely to make a mistake, believe me. Okay, let's get down to this particular question. So, in this question, they want us to express Cindy's age, right? So let's take it as C. So let me write it down. So Cindy, right? Cindy, and her age is age. She is C years old, right? Okay. The problem says that Ashley, I'm sorry, not Ashley, but Sarah. Hold a second. Ashley is younger than Sarah and 3 times as old as Cindy. Yeah, exactly. Ashley is 3 times as old as Cindy. So if Cindy is C years old, Ashley is older, and her age is 3 times as Cindy's. It means 3 times C years old. Also, we know that Ashley is 7 years younger than Sarah. So that means Sarah's age is greater. So Sarah is older. I'm sorry. Sarah is older, right? Which means that older than Ashley by 7 years. It means that we should add 7 to 3 times C, where 3 times C is Ashley's age, and Sarah is older than Ashley by 7 years. Okay, for that reason, we just derived, let's say, the expression, algebraic expression, which shows Sarah's age 3 times C plus 7. So the right answer is E. I hope that it was easy for you. So let's proceed to the next question on here it is. So if R and S are both odd numbers, which of the following must be an even integer? Okay. Now, first of all, let's remember that an odd number can be expressed through the formula twice integer n plus 1, okay? But we've got let it be r, so r is equal to twice n plus 1, okay? But we've got two odd numbers, odd numbers, and the other one is s, which can be expressed through the following similar formula twice m plus 1, okay? Now, let's plug these expressions into each of the formulas to see whether the outcome is divided by 2, having an or yielding an even integer or not. So let's take a look at the first. So r plus s over 2 is equal. So instead of r, we are writing twice n plus 1 plus, instead of s, we are writing twice plus 1 over 2, right? Okay, and we've got twice n plus twice m plus 2, because 1 plus 1 gives 2, over 2. So yeah, I guess it's as clear as it is. We've got n plus 1, because we can put 2 out of the brackets, and they will cancel each other, the 2 in the numerator and 2 in the denominator, okay? And finally, we'll get n plus 1. But it means only one thing, that this number cannot be an even integer, because it is clear that it's not divided by 2, yielding an even integer. Let's take a look at B. R times S over 2. Okay. Okay. So nothing. All we see that this ratio isn't an even integer, because it's not divided by 2. If we divide this by 2, it won't yield an even integer. It won't result in having an even integer. Okay, so C, r times s. R times s is this expression. Okay, and if we divide this expression by 2 inwardly, we will finally get this expression, and it doesn't it doesn't lead to having an even integer either. But if we take a look at D, it is as clear as a day that this number, the product of 2r and s, is an even integer, because we can divide it by 2, and these two numbers will cancel each other, and we'll get rs. So it means that D is an even integer for sure. And 3 times r times c isn't, and it isn't, because 3 over 2 isn't an even integer. It's 1.5, and 2 over 2, yes, it's 1. For that reason, 2 times r times s is an even integer. I hope that my logic of thinking is clear to you. So let's proceed to the next question. Here it is. John buys 40 sacks of flour for Y dollars. So Y is the sum of money John paid in order to buy 40 sacks of flour. At the same rate, how much would it cost to buy 12 sacks of flour? Okay, let's do that. So we know it's the matter of proportion, an ordinary proportion, which helps a lot of time in many cases when it comes to dealing with such relatively easy arithmetic operations. Okay, we've got 40 sacks. Okay, 46, and he paid Y dollars, okay, which means that one sack cost, so one sack of flour, costs Y over 40, right? 1 over 40. And he wants to buy, or somebody else wants to buy 12 sacks, right? So if one sack of flour costs Y over $40, so in order to find out or calculate the sum of money somebody needs to pay for 12 sacks, we need to multiply this rate to by 12. And finally, let's write it, sum is equal to 12 sacks of flour times Y over $40 per sack, and we'll get finally dollars, so it means 12 times Y over 40. So we can simplify this fraction by dividing both the fraction, the numerator and denominator by 4, and we will get 3 times Y over 10. For that reason, the right answer is D. The right answer is D. Also, in the beginning, I mentioned the word proportion. It is easy to be used. Look, 46, right? 46 cost Y dollars, right? And 12 sacks, let's say, is the sum of money we're looking for, right? So sum times 40 is equal 12 times Y. And from this expression, we can express sum, yes, etc. Easy. Okay, now let's proceed to the next question. Here it is. So we got somebody by name Alex, and this person can fold 12 napkins in X minutes. So within X minutes time, so this guy can fold as many as 12 napkins. How many napkins can he fold in Y hours? So the catch about this problem is that in the first half of the problem we've got minutes, right? Whereas in the other one we've got hours, and this is the trap of this problem. Be careful about that. So let's write down first of all let's say the speed of Alex making napkins. So he makes 12 napkins within X minutes, right? X napkins within X minutes. Okay, this is the speed of the production, or the productivity of Alex's work. Now we can write a proportion. So 12 napkins are made within X minutes, right? And we are supposed to calculate the number of napkins which can be made within an hour, but we cannot write within Y hour. We cannot write down Y because Y is hours, and X, the measurement units of X, minutes. We cannot do that. For this reason, first of all, let's change something about this proportion and find out how many napkins can be made within 1 hour. But 1 hour cannot be written here in this proportion either because of the measurement units, minutes and hour. But we can do this problem over very easily, remembering that there are 60 minutes in 1 hour, right? So in this case, n is equal 12 times 60 over x, or 720 napkins over 720 over x napkins within 60 minutes, or what is the same, within 1 hour. Okay, and we've got y hours. We know that within 1 hour 720 over x napkins are made, and it means that the total number of napkins is the product of n and y, or 720 times y over x. This is the answer for this one. Let's see. Well, thank you that you are still with me. And now we're proceeding to the next question. Here it is. Alice. So this girl had to read as many as 350 pages of a book over the weekend. If on Sunday she read 50 pages more than half the amount she read on Saturday, how many pages did she read on Sunday? Okay. First of all, I want to say that I know for sure that a lot of American schoolgoers don't like to use algebra, and they prefer to put in uh, the values given as options to choose from in order to work out a more or less maybe logical answer, okay, a plausible answer. Well, I am okay. I belong to another school, and I like algebra, and I believe algebra is a really universal mathematical dialect which helps in many situations, and this is not an exception either. So first of all, let's see that we can say that the number of pages read by Alice on Sunday, I'm sorry, on Saturday is X. So let me write down. So on Saturday, she read X pages. Okay. And half of this amount is 0.5 times X, right? And the problem says that on Sunday, she read 50 pages more than half of that amount, of the Saturday's amount. If the Saturday's amount is X, half of it is 0.5 times X. That means that on Sunday, she read 0.5 times X plus 50, because on Sunday she read by 50 more than a half of what she read on Saturday. I've just translated, I just want to repeat it, I have just translated these words into the language of algebra, okay? And I know that the total number of pages she read is 350, right? That means that the logical foundation is that Saturday's number plus the Sunday's number, okay, is equal to 350. So we should plug in this, I mean here and here, into this formula. Okay, what do we get? X, this is the number of pages that she read on Saturday, plus 0.5 times X plus 50. This is the number of pages she read on Sunday, and totally is equal to 350. Okay, it means 1.5 times X is equal to 300, and X is equal to 300 divided by 1.5, and we got 200. It means that on Saturday she read 200 pages, but they want us to find out the number of pages she read on Sunday. For that reason, we add 50 No, not 15. So on Saturday, so how many pages did she read on Sunday? Uh-huh. So now we know that she read 200 pages on Saturday. On Sunday, this is the mathematical expression. So 0.5 times, instead of x, we lap in 200 plus 50, right? I'm sorry, plus 50. This is 100 plus 50. We got 150 pages. For that reason, the right answer is A. That's it. Yeah, on Sunday, and we got on Saturday. Uh-huh. So let's proceed to the next question. It is very tricky, I should confess. Tricky because everything seems to be plausible, but actually it's not. Uh, it's not correct. So what I mean is the following. You should double check all the options offered for your consideration to make the right choice. Now, what we got? We got the product x and y. We got two unknowns, x and y. Okay, x and y, and its product is less than 0. Okay, so x times y is less than 0. What does it mean? It means only one thing, that x and y, one of the two unknowns, is negative. One of the two is negative. And in this particular case, we cannot conclude which of the two is negative and which of the two is positive. And actually, it doesn't necessarily, it doesn't play a role. It's not important to know which of the two is negative. All we need to know to choose the right answer is that either of the two is negative. So from this, we can induce that either of the two unknowns is I'm sorry, is negative. Okay. Now let's take a look at the first option offered. X plus y is equal to 0. Actually, it can be true. It can be true. When the absolute values of the two unknowns are equal to each other, if the modulus of x is equal to the modulus of y. In this case, yes, it could be true. However, it's not for sure because we don't know if the two unknowns, their absolute values are equal to each other or not. We have no idea. We are considering a very, let's say, general solution. For that reason, one is not the absolute correct choice, if I may say like this. Let's take a look at the second. So twice x minus twice y is less than 0. So if we've got an inequality, yes, and if we divide both the left and the right side of this inequality by 2, nothing will change because we divide not by 0 but by 2, and 2 is positive, which means that this sign will not change. So it's equivalent to the inequality x minus y is less than 0. Let's take a look. We know for sure that one of the two unknowns is negative. For example, if x is negative, if x is okay, let's take a look. For example, if x is negative, then y is positive, because we know that only one of the two unknowns is negative. In this case, we will get a negative number minus a positive number, which means a negative number 2. And when we add two negative numbers, we got a negative number. And it seems to be plausible. But the key word in this sentence is seems, because we can have another situation when when x is positive and y in this case will be negative. And what we will get? We will get a positive number minus a negative number, minus minus. And finally, we will get the sum of two positive numbers, positive values. And it's positive and it cannot be less than 0. In this case, it's partially correct only when x is negative and y is positive. But again, we don't know which of the two unknowns is negative and which of the two unknowns is positive. For that reason, 2 cannot be an absolute correct answer either. Let's take a look at the third one. X squared plus y squared. It is very clear, as clear as a day, that any squared number, regardless of its sign, I mean, regardless of whether it is negative or positive, when its value is squared, it always results in something positive, right? And here is the we've got it here. One positive number added to another positive number will get will finally result in a positive number 2. And this is the case. For that reason, the only correct answer is option B, 3 only, because this is correct at any value of x and y. I hope that my logic of pondering is clear to you. So, I hope that you haven't lost your interest in my video yet. And now we are proceeding to the next question from this set of SAT assignments. And here it is. It says that Alan, Fred, and Mark, 3 friends, I guess, are going to purchase a computer that costs $540. So they want to chip in, right? In America, they use the CDN, this variable chip in when there are a few people who want to share the expenditures. In this case, we can say chip in. That's for you if you want to improve your speaking skills. Okay. Oops. I did it again. Okay. So these 3 guys want to purchase a computer that costs $540. Alan pays $40 more than Fred, while Fred pays twice as much as Mark. So, and the question is, how much does Mark pay? You know, the golden rule of algebra is, in text questions, is what they ask you about should be taken as x. Let's follow this rule. They want us to determine the amount of money Mark is willing to pay in order to buy the computer, and let it be x. So I am writing Mark x dollars. Okay. Now we are following backward. So we've got that Mark is ready to donate. Let's use this word, donate x dollars in order to pay for the computer, and Fred pays twice as much as Mark. So if Mark pays x dollars, so Fred pays twice that amount. It means 2 times x. Okay. And Alan pays $40 more than Fred's amount of money. So in this case, Alan So 40 plus twice x, and this sum plus this sum plus this sum is equal to 540. It's logical, I guess. It's clear. So x plus twice x plus 40 plus twice x is equal to 540. Again, this is the total amount of this is the price of the computer. This is the amount of money Mark is ready to give. This is the amount of money Fred is ready to share, and this is the amount of money Alan is ready to put in. Okay, in this case, we've got x plus 2x is 3x, 3x plus 2x gives 5x. Okay, and I'll put 40 to the right part of this equation. 540 minus 40, because when I put it onto the other part of the equation, so I have to change this this sign. In the left side, 40 has got a positive sign, and if I put it on the right side, so it will become minus 40. So 540 minus 40 gives 500. Or I've got 5 times x is equal to 500. I guess it's absolutely clear that x is equal to $100. Okay, it's 100, but this is the amount of money Mark is ready to pay, and this is what they ask us about. Mark. For that reason, the right answer is A, option A. I hope that it is clear. However, let me show you. Let me show you another way how you could crack this problem. And the word crack is absolutely not groundless to be used, because you are not working out the mathematical model of this problem, as we have just done. I call it guessing. Let's take, for example, 240. Let's assume that it might be the right answer. So Mark gives 240 bucks. Okay. In this case, Fred gives twice more than that, twice as much as Mark gives. So it means that Fred gives 2 times 240, 280, 480, I'm sorry, dollars is that amount of money which Fred is ready to give. Excuse me. But in this case, if we add these two numbers, 240 plus 480, that'll be more than 540. Yes, it's 720. And it's not logical, because in this case, Alan's money is not needed at all, because this amount of money of these two guys is more than enough to buy the computer. But we know for sure that Alan also gives his money. For that reason, this option should be eliminated now, or excluded, or crossed out. Okay. Now D, 200. If Mark's amount is 200, that means that Fred's amount is twice that amount, 400, right? So we can take choose another color. So Mark 200, Fred in this case 400, and if we add these two, we will get 600, right? And again, the same situation. 600 is more than the price of the computer, and it excludes Alan from the corporation, from financial corporation. But we know for sure that Alan does give his money. In this case, we got a logical controversion, right? And we should exclude this option too. Let's take a look at option C. So Mark gives $160, right? And Fred, in this case, gives twice that number. It means 320, right? 320. So if we add, we got 480, not enough to buy this. Okay. But in this case, Alan gives 400 more than this amount. And if we add 40 to 320, we'll get 360. Okay, 360. In this case, we got this sum, which is much more than the amount of money we actually need, which excludes this option 2. What about option B, 140? So let's check it too. So Mark gives $140, right? In this case, Fred gives twice that number, 280, right? And Alan, in this case, gives 320 because his input is $40 more than this one. Let's add this. If we add these three numbers together, we will get, oh, okay, 300, 420 and 740. Yes, if I'm not mistaken, it's much more than enough. In this case, we got a weird situation when Alan gives much more than it's necessary. In other words, Alan gives nothing or shouldn't give any money at all, but we know that he gives money. So we exclude these two. And the only option which is left behind is this one, which is left is this one, 100. Let's check it. Maybe it's not correct. Who knows? I'm joking. Okay, which color to choose? Let it be red. Okay. So Mark gives 100. Okay. Fred gives twice that, 204. And in this case, Alan gives 240. Yeah. If we add these two numbers together, we got exactly $540, what they actually need to buy the computer. So as you see, this way of solution doesn't incorporate any unknowns such as x, which I did in my version, in my way of solution, and it doesn't do anything with algebra at all. It's like guessing, but logical guessing. So if this way is more convenient for you, so why not? It's also workable and you can use it. But in my, again, not humble opinion, my way of solution when we exploit unknowns, when we work out the logical mathematical models of the situation, it's much better. It's much more productive for our thinking. I guess so. But you may disagree with me. This is your right. Okay, guys, let's proceed to the next question. It's another problem, and I hope that you will be able to follow my logic. Okay, Ali has three fewer than twice the number of coins that Jonathan has. If Jonathan gave 2 coins to Ali, she would have 3 times as many coins as he would. How many coins does Ali have? Okay, in this particular case, they are asking us about the number of coins Ali has. But actually, I can show you that it is not very important in this case, which of the two characters of this problem, I mean, either Ellie or Jonathan should be, how to say, should be, whose number of coins should be expressed through X. This is what I wanted to say. For example, let it be Jonathan. So Jonathan, initially, or in the beginning, Jonathan has X coins. Okay. And Ellie, where is it? Has 3 fewer than twice that number. So twice that number is 2 times x, right? And 3 fewer. That means that we subtract 3 from 2x. This is the number of coins Ellie has. I hope that it is clear for you. Okay, but this is only the beginning. It's only the start. Now, if Jonathan gave 2 coins to Ellie, so initially Jonathan has X coins, and if he gives 2 coins, he finally has X minus 2 coins. Yeah, this is the number of Jonathan's coins finally. But these 2 coins don't disappear anywhere. They get into Alice's collection. So initially she has twice x minus 3, and she finally gets 2 more coins, which means that in the long run she has got twice x minus 1 coins. Okay, this is Ellie's number of coins, and x minus 2 is the final number of Jonathan's coins. And the problem says that after that, Ellie would have 3 times as many coins as he would. So now we know that x minus 2, which is the number of coins Jonathan would have, is less than the number of coins Alice would finally have. Yes, twice x minus 1. How much times? 3. 3 times. You can write by 3 times. In order to make this inequality into equation, we should multiply one of the sides, either the left or the right, by 3. And this is a very good question. Look, if we choose the right part of the equation in order to multiply it by 3, we will make the larger part, because this part is larger than this one, yes? We can make the larger part even much larger. And in this case, we will never get equality, right? Logically, we should multiply the lesser part, the smaller part, in order to get equality. So we write like this. And this is the logical equation, or as we say, the mathematical model of this situation. We open the brackets, as we say in Russian. I don't know how it is in English brackets, but yeah, I guess it's the same. We multiply the terms in the brackets by 3. Okay, and all unknowns we put into the left side, and all constants into the right parts, into the right part. And so we remember that if I put twice x from the right side into the left side, I change its sign. In the right side, in the right part is positive, which means that in left side it will get the negative sign. The same is applicable to this constant. In the left part of this equation is minus 6. In the right, it will be plus 6, minus 1. So 3x minus 2x is x, and 6 minus 1 is 5. So 5 is the root of this equation. And what is x for us? X is the number of coins Jonathan has initially. But the question is, how many coins does Ellie have? So we plug 5 into this expression, and we will get 2 times 5 minus 3, which is equal to 7. So the right answer is D in this case. I hope that this logic is clear to you. So let's proceed to the next question. We got let's call it a formula. Twice t plus no, it's an equation, better say, yeah. Twice t plus s minus r in over 3 is equal to r. And they want us to express s through r. No, I guess I misprinted this assignment. What is s in terms of r and t, actually? I'm sorry. Oh, let me correct it. Of course, t. Yes. Now just correct. Thank you. So they want us to express c through r and t. First of all, let me rewrite the initial equation. Twice t plus s minus r over 3 is equal to r. Okay, so we need s, right? For that reason, I put this term to the right part, changing its sign, and I've got s minus r over 3, s minus r over 3 is equal to r minus double t, right? Okay. Now I don't need s with something over 3. In order to say goodbye to the denominator, I multiply both sides of this equation by 3. Okay. In this case, 3 and 3 will cancel each other, and we've got s minus 3 is equal to 3 times r minus double t, which is equivalent to the following. So it's 3 times r minus 6 times t, right? Okay. In this case, I don't need s minus r, I need s only. For that reason, I put r to the right part, and I will change the its sign. On the left side is negative, but in the right it will be positive, and I will get 3 times r plus r, which will be 4 times r. So s is equal to 4 times r minus 6 times t. Yes. What can I do in this case? I can put 2 as the common factor out of the brackets, and I will get 2 times r minus 3 times t. And I've got the right answer. I guess it's C, right? Yeah, it's not a difficult assignment, absolutely. Thank you.